Hi everyone, today we will have a solution session. In this session we will discuss about the solutions of exercise 1.2 from set theory. The first question goes like this. I am directly going to the question, expecting that you have seen the videos of theory, and if you have not, please go back and check the videos on the theory part. We will be discussing about null set, equal sets, finite sets, infinite sets. So kindly check the videos and then come back and continue with this video. So first question goes like this: which of the following are examples of null set? In that, first sub question is set of odd natural numbers divisible by 2. Set of odd natural numbers divisible by 2. Let us check if we can write the elements of this set. If you can write the elements, that means it is not null, even if a single element exists, like example 0. 0 is also an element, so if one element exists, then it is not null. Fine. So they are asking you odd natural numbers divisible by 2. Let us see. First of all, what is odd number? A number when divided by 2, it should give you a remainder of 1, that is odd number, correct? But here they are saying it should be divisible by 2. Divisible by 2 means the remainder should be 0. Odd number definition itself is, for example, 3 is an odd number. If you divide by 2, 2 ones are 2, remainder 1. If remainder 1 is there, then that is not clearly divisible by 2, right? It is not divisible. Any odd number if you take, it's always in the form of 2n plus 1. Always it is in the form of 2n plus 1. 2n, if you divide 2n by 2, 2n by 2, 2 n times, n into 2 is 2n, remainder is 0. Suppose plus 1 was there, you divide 2n times is 2n, then continue, remainder is 1. So any number which can be written in the form of 2n plus 1 will always give you a remainder of 1, because of which it cannot be divisible by 2. It is from Euclid's lemma of 10th standard. You have learnt that any even number will be written in the form 2n, any odd number can be written in the form 2n plus 1. Means odd numbers are not clearly divisible by 2. There will be a remainder 1. Whereas even numbers are all divisible by 2. They asked you odd natural numbers, and that too which are divisible by 2. There is no odd number which can be divided by 2. That means the only elements possible in the set is nothing. Nothing can be written inside. So that is a null set. Let's go to the next question. Second sub question goes like this: set of even prime numbers. Set of even prime numbers. See, let me call it as set B. You can name it anything. I do just to B. You can call it P also for prime numbers, no issues. Numbers when we are considering, it starts with 2, 3, 5, 7, right? 11, 13, it continues like that. If you look at the first one, that is 2. Is it a prime number? Yes, it is a prime number. Is it even? Yes, even prime number. All the other prime numbers, if you check, they are all odd. 3, 5, 7, 11, 13, all of them. Reason why other even numbers are not there? You take any other even number, 4. It is divisible by 2. It is a composite number. It is not a prime number. So, sorry, 4 cannot be written. What about 6? 6 is 2 3s are 6. So, it is a composite number. A prime number should be only divisible by itself and 1. There should be no other factor. Whereas for 6, there is another factor. 6, 1 and 3. So, it is a composite number. So, you cannot write 6. How about 8? 2 4s are 8. There is another factor 4. How about 10? 2 5s are 10. So, 5 is there, another factor. Right? 2 and 5 are there. So, all the other numbers other than 2, any even number if you take, they are always non-prime. They are all composite. All the others are odd. So, they have asked you even prime number. There is only one even prime number, that is 2. It is a singleton set. But is it a null set? No. So what can you say? No, this is not a null set. So first sub question was a null set. Second sub question, not a null set. Even if you have one element, it may be 0 also, or 0.000001, any small number, it's okay. It's a negative number, chalega. But if nothing is there inside, only then it is a null set. Here 2 is there, because of which it is a singleton set. It is not a null set. Okay. Next one, third one, it is a set x, set of all x such that x is a natural number. Okay, x is a natural number. So x belongs to n. You know, 1, 2, 3, 4, 5, 6, like that. X is less than 5 and greater than 7. See, some people get confused. Sir, 6 is the number. No, because see what happens here. They are asking you numbers which are lesser than 5 and which are greater than 7. Take all the natural numbers less than 5. 1, 2, 3, 4. These are the numbers. Are they bigger than 7? No. This should satisfy both the conditions. It should be lesser than 5, greater than 7. That is not possible. For example, think there is a joyride in a theme park. They say only those people who are above 6 years are allowed and below 20 years are allowed. So, do you find people like that? More than 6 years, less than 20 years? Yes. 7-year-old, 8-year-olds, 9-year-olds, 10-year-olds, like that continues till 19-year-olds. All can sit in that ride. You will find people. But if a condition comes like this in one ride, those who are above 4 years are not allowed, and the same person should be more than 60 years. A person who is less than 4 years and greater than 60 years, only they can go. If a 62-year-old person comes and says, I want to go for the ride, they will say, no, you have to be lesser than 4 years. You are not, sir. So, cancel. And if you take a small child of 3 years old and say, this child can sit because it is less than 4, then they say, no, no, because the same child should be greater than 60 years. Only then they will allow. That is not possible. Correct? So, think this is the age. Which person will be there who is smaller than 5 years and who is elder than 7 years? It is impossible. There is no number which can satisfy this condition. The reverse condition is possible. The ulta is possible. See how? Greater than 5 and lesser than 7, both. This is possible. Greater than 5, 6 is lesser than 7. Yes. So, there is one possibility, which is that 6. When is this? See, if you write like this, x should be less than 7, the same x should be greater than 5. This is possible. If I write this together, this one, it looks like this, 5. The number should be less than 5. So, 5 should be greater than that number. The same number should be greater than 7. This does not exist in mathematics. So, this is a null set. Clear? The number comes between 5 and 7, but not exactly between. I cannot say the between word here. It should be greater than 7, lesser than 5. This is not true. True? Understood? Fine. So, this is a null set. So, the third one answer is a null set. Let's go for the fourth sub question. There is a last sub question for this main question. Set of all y such that y is a point common to any two parallel lines. Y is a point common to any two parallel lines. See, actually this is a controversial question. It's a controversial question because there are certain proofs in geometry where you will find points, okay, innumerable points common on two lines. When two lines coincide on each other, if they are parallel and they coincide, we can prove that it is a one and the same point we are talking about. But here, we will not go for that argument. Here the meaning is, two lines are parallel. I will call it L1 and L2. Take any number of points on this. Here also you take any number of points. These 2 points cannot be common because the two lines will never meet. If they were non-parallel, see these two, for example, I will call it L3 and L4. After extending for a long time, they may come and coincide. They may cross each other, provided that they are on the same plane. If they are on the same plane, they both will intersect. If they intersect, then that will be a common point. If you find a common point there, then automatically it is not a null set. But talking about L1 and L2, let's come back to L1 and L2. They both are parallel. Parallel means no matter how much you extend on both sides till infinity, minus infinity and plus infinity, go on extending, they will never intersect. If they don't intersect, then there is no common point. So what can you say? The common point set, the set which contains the common point is null set. So that's the question number, main question number 1 answers 4 sub questions we have cleared. Thank you. Let's continue with the second main question. So let us continue question number 2. So which of the following sets are finite and infinite or infinite? We have to find out whether they are finite or infinite. If you have seen the video already regarding the theory on finite and infinite, you know that if we can count the numbers exactly, if we have the number of elements perfectly we know, then we can call it as finite. If the number of elements is uncountable or infinite, then it is called as infinite set. Very direct definition. So let us apply that. First sub question in second main question. Let's go. The set of months of a year. The set of months of a year. Yes. Is the number of elements, you know how many months are there in a year? Yes, of course, there are 12 months. You know them. January, February, March, April, May, June, July, August, September, October, November, December. Over. You know the starting point and ending point where it stops, and the number of elements is finite. That's for first one is an finite set, right? Okay, let us go for the second sub question. Second sub question says 1, 2, 3. Let me name that set as A is equal to 1, 2, 3, and the dots, 3 dots are enough. 3 dots always indicate that continues, it doesn't stop. So we don't know where it stops. This is nothing but actually natural numbers. You can also equate it to n. There is no need of calling A also, you can call it as n. Set of natural numbers or counting numbers start from 1. 1, 2, 3 continues till no end. So since there is no end for this, the number of elements is infinite, we can say this is an infinite set, right? The first one was a finite set, second one is infinite now. Okay, I'll just add up all of these together and write at the end. Just remember, first one was finite, second one is infinite. Now third one, 1, 2, 3 goes on till 99 and 100. Okay, the same question, almost small change. I'll call it set B. Let me call it B is equal to 1, 2, 3 and ending with ... continues, and finally after continuing it comes and stops at 99, 100. So fixed it is. How many numbers are there here? They have not written all the elements. In roster method, when 2 huge ones are there, very big sets, we don't write all of them. It is too much time consuming. It is not impossible, time consuming. So in short we write it as 1, 2, 3 ... 99 and 100. How many elements are there? 100 elements. You know the number exactly. 100 elements means this is finite. Okay, the third one is finite. I'll just write a shortcut and leave it here so we can just sum up at the end. The first sub question was finite, the second sub question was infinite, the first one was I think that's about the months, right? 12 months. This is infinite because natural numbers. Here also natural numbers, but within the limit from 1 to 100. So this is finite. Let's go for the fourth sub question now. The fourth sub question says that the set of positive integers greater than 100, set of positive integers, let me call it as maybe C. Okay, set C is equal to positive integers. Integers, you know, they are 0 in the middle, negative on one side, positive on one side. We are only taking the positive, only positive. So only positive means 1, again it is counting numbers, 1, 2, 3 like that. These are the positive numbers, but they are asking positive numbers which are greater than 100. So greater than 100, we don't need these numbers. We will start with 100, 101. This is strictly greater than 100, right? They have not asked greater than or equal to. If they had written greater than or equal to, you should have started with 100. They told strictly greater than 100, means 101, 102, 103. Where does it stop? Since they are nothing but natural numbers, counting numbers or positive integers, they have no end on that side. So this is an infinite set. So what can you say about the fourth one? Infinite set, correct? Next, let's go to the fifth one, fifth sub question. The fifth sub question says that set of all prime numbers less than 99, all the prime numbers. If you just make a note of all the prime numbers, right? We'll start with prime numbers, I'll call it P, sorry, not here. These were the answers we were writing. So P, prime numbers, starts with, you know, 2, 3, yes, 5, 7, and continues 11, 13, like that it goes on. What is the last prime number from 100? Let's try checking reverse. 100, is it a prime number? No. 99, definitely not. 98 is an even number. Even numbers are always divisible by 2. 97, 97, no, 97 doesn't have any factors other than 97 and 1 itself. So 97 becomes a prime number. So we will stop it at 97. So this continues till 97. So since you can write the last term, so first term to last term, all numbers you can. It takes time consuming, but if you write all the elements here, you can complete the set. So you know exactly how many prime numbers are there. So there are 25 numbers. Since you know the number of elements exactly is 25, you know where it starts and where it ends, it's countable, hence this is a finite set. So that is finite. Here you go. These are the solutions for second main question. Let's go for third main question. Main question number 3, state whether each of the following set is finite or infinite. Sub question 1, the set of lines which are parallel to the x-axis. Nice question here. Sub question 1. I'll consider this as x-axis. Okay, I'll just for the reference, I'll draw the y-axis too. Okay, here you have x and y. So those lines which are parallel to x-axis. So if you see any other line on the any point on the y-axis, for example, y is equal to 1 and y equal to 2, y equal to 3, y equal to 4, these numbers continue till infinity. Okay, it's one more number line that's going to continue till infinity. It also extends on the other side, -1, -2, -3 till infinity. If you draw a line through 1, we can see that it is parallel to x-axis, right? Any line whose equation is x equal to 1 or x equal to 2, x equal to 3, like this. X equal to 1 is this line, x equal to 2 is this line. Another line which is parallel to x-axis, x equal to 3, a line which passes through 3 and is parallel to x-axis. This can go on continuing, x equal to -3, for example, the line which passes through -3 and is parallel to x-axis. Not only these infinite points, there are other lines also in between. See here, between 1 and 2 there is 1.5, x equal to 1.5, that is also parallel to x. X equal to 1.3, 1.2, 1.1, there is 1.001, then 0.001, 0.0001, 0.00001. So there are innumerable lines, infinite lines which are parallel to the x-axis. So this is an infinite set. So the first first sub question is infinite. Okay, let me mark that. First sub question is infinite. Let us go to look at the second sub question. Second sub question, the set of letters in the English alphabet. You know the English alphabet. Let me call it as set A itself. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, W, X, Y, Z. So N, Z, Z. And we know that there are 26 letters in the alphabet, which is a finite number. So this is a finite set. If you can say how many number of elements are there, that means it is finite. It may be big one. For example, numbers from 1 to 10 crores. Yeah, it's natural numbers. I mean natural numbers from 1 to 10 crores. There are a lot of numbers. So it's a huge set, but it is finite because we can say how many number of elements are there. So second one is finite because we know the number of letters exactly. Let's go for the third sub question. The third sub question says set of numbers which are multiples of 5. They have not mentioned natural numbers or integers or whole numbers, rational numbers, nothing, just multiples of 5. Let us say take the smallest of all the sets, natural numbers. Compared to other sets, natural numbers is the smallest. So, in natural numbers I will consider multiples of 5. I will call it B. Set B is equal to 5, 10, 15, 20. They have not told where to stop. Means this thing continues. This continues till infinity. There is no end here. That means it is an infinite set. So, third one is infinite set. Okay, let us come to sub question number 4. Sub question 4, the set of animals living on the earth. See, it is kind of little controversial and ambiguous question because though it is a huge number of sets, it is a humongous number of sets, but when you are talking about animals, are you preferring only the bigger ones which we can see, or are you going to count the bacteria and insects, everything together? Like animal kingdom, if you are talking about. Animals means even birds, insects, and maybe bacteria, viruses, everything start getting into it. So, when you have a huge set like that, by the time you finish counting, they have already produced new young ones and they also go on adding up. So, you can say it is an infinite set like that. But if you are talking about strictly only the animals, like birds are not counted, insects are not counted, only the multicellular bigger organisms like cow, dog, cat, elephant, like that, these wild and domestic animals only if you are talking about. In that sense, population of each type can be taken, like population of tigers, population of elephants, right? An approximate number can be taken. And if you take like that and add up all the animals, right, start writing, it is a huge number, but it will be finite. Because population of each animal can be taken into consideration separately and then added up together. Fifth sub question, the set of circles passing through the origin. Now here you may get confused here a little bit. If you consider the Cartesian graph in this, if you consider the origin, here comes the origin, right? In this origin now, if you consider circles passing, origin is not the center, not this type of circle, not these circles. These circles have origin as the center. They are asking circles which pass through origin. So, how do they look? So, these are the axis, y axis, x axis, this is the origin. So, imagine a circle like this. It is not an exact circle, it looks like an ellipse, but consider it as circle. A circle which passes like this. Okay, maybe another circle. See, this is one more circle which passed through that. Maybe a smaller circle, maybe another small circle, like this. You can have any number of circles which any one point passing through origin, any one point. Okay. So, if you go on drawing like this of different sizes, just imagine on one direction itself I can have infinite circles, just in one direction. Like that many directions are there. Here I have drawn from every different direction. Just look at one direction, okay? Just one direction. Once more, I start with the origin, the axis, right? So imagine, I am going along y axis now. This process can continue. Had I had such a big board and lot of pen and time to go on writing this, I could continue this process infinitely, because imagine the radius is like 1, 2, 3, 4, 5. The radius goes on increasing. So, what is the last radius that you can draw? What is the biggest radius that you can draw? Infinite. There is no number. Can you say like, okay, 10 crores? You can obviously write 10 crore 1. 10 crore 2, okay, 100 crores, okay, 100 crore 1, they are always plus 1. So, how many radii can I go on drawing? Infinite. That means the number of circles passing through this point, 0, 0 origin is infinite set. Okay. So, the last sub question is also infinite set. Hence, third question. Let us go for the fourth one. Question number 4 says that in the following state whether A is equal to B or not. So, in every sub question you are going to get two sets A and B. You have to check whether A and B both are same. So, what they do generally is they either mix up the order of the elements in both of them, because they will not look identically same, or one will be in roster method, another one will be in rule method. We need to convert it into one form and then check, preferably roster method. Now, the first sub question, let us see. Set A is AB. Question 1, A, ABCD and B, DCBA. If you write both of them, A is equal to A, B, C, D and B which is equal to D, C, B, A. Here you go, A, same, B, element same, C, element same, D, element same. All the elements are same, only their orders are different, but order doesn't matter. So, you can say that A is equal to B, that is sub question 1. Now, let us go to sub question 2. So, sub question 2, A is equal to 4, 8, 12, 16. 4, 8, 12, 16 is 4, 8, 12, 16 and B is equal to 8, 4, 16, 18. 8, 4, 16, 18. Now, see, to prove that they are equal, you have to see that all the elements are same. To prove they are not, you just have to pick out one, any one enough. For example, here 4 already there, 8 already there, 12 not there. So, that is enough for us. 12 belongs to A, but 12 does not belong to B. Just write that much and you have proved that A is not equal to B. So, to prove not equal, just one example is enough. Okay, I am taking 12 belongs to A, but 12 does not belong to B. That implies A is not equal to B. So, that is sub question 2. Third sub question goes like this. Set A is equal to 2, 4, 6, 8, 10 and set B is set of all x such that x is positive even integer and x is less than or equal to 10. So, it is positive even integers. So, even numbers if you take integers, positive ones, negative ones you forget it. Ultimately they are saying natural numbers which are even, that is indirectly what they are saying. Now, what are they? 2, 4, 6, 8, 10, 12, 14, 16 continuous, but they have given one more condition, less than or equal to 10. So, less than or equal to 10 means just to agree, does to agree with the fact that it is less than or equal to 10? Yes, it is less, fine. Can we write 4? Yes, of course, it is less than 6, yes, less than 8, yes, less than 10. If it was strictly less than, then 10 would not have come, but they have given less than or equal to. If less than or equal to is there, then yes, 10 also can be taken. See, once more I will repeat, if x was less than 10, this is called strictly less than, means you can't use 10, but they are given less than or equal to, means 10 also can be considered, means you can take all the same elements. Compare between A and B, right? All the elements are same, right? Yeah, 2, 4, 6, 8, 10, right? All of them are the same elements, means A is equal to B. We can just say A is equal to B because the elements are matching, fine. Okay, now we will go for the next sub question. Sub question 4 says that A is a set of all x such that x is a multiple of 10 and the set B is a roster form, is in roster form. It is given as, let me see, 10, 15, 20, 25, 30. Let us write both. Okay, A. Multiples of 10. Actually, they have not mentioned anything like integers or whole numbers, natural numbers, nothing. So, we will be taking it as natural numbers. I will be taking only positive ones. That is 10, 20, 30, 40. They have not told till where. The limit is not told. Whether it should be more than a number or less than a number, nothing is told. That means this continues without end. So, it is an infinite set. Now, comparing with set B, which is in roster form, 10, 15, 20, 25, 30, etc. Now, if you can check 10, yes, it is same, 20 it's here, 30 is also there, but 15 which is there in B is not there in A. Even if you find one element which is not same in both, that is enough to say that they both are not equal. So, you can say 15 belongs to B, but 15 does not belong to A. Therefore, A is not equal to B. A not equal to B. That's it. Question 5 goes as follows. Are the following pair of sets equal? Give reasons. So, now they are asking about reasons. Let us check that. Sub question 1, A is 2, 3 and B is equal to set of all x such that x is a solution of x square plus 5x plus 6 equal to 0. So, you have two sets here, A which is equal to 2, 3, roster form directly, then B set of all x such that x is a solution for the equation x square plus 5x plus 6. Means, what do you mean by this? Means, if you equate this to 0, then the values which satisfy that equation are called as the roots, or they are the values of x. So, let me solve that. X square plus 5x plus 6 equal to 0. So, splitting this further, it is 3x plus 2x plus 6 equal to 0. Here x into x plus 3 from here, this from the first one, from the second one plus 2 comes out. So, x plus 3 equal to 0. Now, x plus 3 is common. So, x plus 3 into x plus 2 is equal to 0. Here, if I check, the product of two numbers is 0, one of them must be 0. Either x plus 3 is 0. If x plus 3 is 0, then x equal to minus 3. Then if x plus 2 is 0, then x is equal to minus 2. So, I got two values, that is minus 3 and minus 2. So, if I write this in the roster form, this is nothing but minus 2 and minus 3. Are they both same? No. Here 2 is there, 2 is not there in the second one. 3 is there, 3 is not there in the second one. Here minus 2 is there, not there. Minus 3 is there, not there. Even if one element does not match in both, we say that they are not equal. So, what can you say about these two sets? A is not equal to B. How will you say that? Just take one element. Example, 2 belongs to A, but 2 does not belong to B. This implies A is not equal to B. Okay? Right. Let's go for second sub. Second sub question says that set A is a set of all x such that x is a letter in the word follow. So, if I write it in the roster form, it is as follows. A is equal to, follow is made up of F, O, L, another L is there, but I will not be writing because repetition not required. Then again O is already written, then W. Okay. Then what about B? B is a set of all y such that y is a letter in the word wolf. So, wolf spelling if I write W, O, L, F. Now, if you compare with the letters in both of them, all the letters are same, right? F, there it goes. O, yes, it's there. L, it's there. W, yes, W is there. So, all the letters are same. Then you can write that as both the sets are same. We can say A is equal to B. That's it. Question number 5. Last question, question number 6. Sixth main question goes like this. From the sets given below, select equal sets. So there are about 8 sets given. We have to compare each one pairwise, one pair at a time, and then discuss. So let me write those sets now. Here goes the question. So these are the sets you see, right? Let us start comparing one with each one separately. Now A I am going to compare with B, C, D one by one. A and B, right from first 2 to fine 4, 4, yes, 8 does not exist in B. A contains 8, does not exist in B, so A and B are not equal. What about A and C? 2 does not belong to C. 2 is there in A, but 2 does not belong to C. That means they are not equal. So A and C are unequal. How about A and D? 2, yes, 4, yes, 8, no 8 in D. So did they ask for justification? They have not asked any justification. So you just have to say whether they are equal or not. So these are not equal. They have asked you to write only equal sets. These are not equal, so we will not be mentioning them. So A and D are not equal. A and E, just by looking at the number of elements you can make out that there are 4 elements, 2 elements, they are not equal. See, to be equal, 2 things are important. First, the number of elements should be same. Second, all the elements also must be same. But if only number of elements are same, you can call that equivalent. That's not equal, they are equivalent sets. The sets with same number of elements is called equivalent sets. But if they are same elements, then we call them equal. So now, what about A and F? They are not even equivalent, because again 2 and 4 elements cannot be equal. A and G, same problem. 4 elements, 2 elements. A and H, not equal, 4 elements, 2 elements. So now A is not equal with any of the sets, so we need not write that at all. So we will leave A out of discussion now. Okay, A, bye bye. A goes there. Now let's try to compare B. 1, 2, 3, 4, 4, 8, 12, 14. Just 1 is not there in C. So B is not equal to C. Right? Now B and D, 1 is there, 2 is there, 3 is also there, 4 is also there. All the elements are same. The order is not important. They are mixed up, but the same elements are found in B and D. So we can write B, set B is equal to set D. We got one pair of equal sets. Next, B and E. Not even equivalent, 4 and 2. Same with F, 4 and 2 elements. 4 elements, 2 elements. So G also is not equal to B. H, again 2 elements. So they are not even equivalent. They are not equivalent, they are not equal. So B, now we are done with B. Let's now start comparing C, right? C and A, C and B we already done. So it's almost like commutative. You don't have to check once more. Now C and D, they are equivalent. They are equivalent because they both have same number of elements. But 4, yes, 8 doesn't appear in D. So 8 belongs to C, but 8 does not belong to D, so they are not equal. And for the same reasons, C is not equal to any of these E, F, G, H, because they are not even equivalent. The number of elements in C is 4. In all the others, they are just 2. So C is not equal to any other set. So I am going to rub it off. There goes C. Bye-bye. And then comes D. It's quite easy now because it is only set with 4 elements. Remaining all are sets with just 2 elements. So D is not equal to any other set. There goes D. Adios, amigo. Okay. E. Comparing E and F. E has 2 elements, F has 2 elements, they are equivalent. All these 4 are equivalent because they are all 2 elements. But -1 + 1, is it -1 + 1 here? No. So E and F are not equal. E and G, their order may be different, but the elements are same. 1 and minus, here, -1 exists, 1 exists. Same elements means E and G are equal. So the second next set is E is equal to G. How about E and H? See, minus 1 does not exist in H, but it is there in E. So, E and H are not equal. They are equivalent, but they are not equal. So, one more set cancelled. So, finally, E goes out. Now, coming to F. F is 0 and A. G doesn't contain 0. So, F and G are not equal. What about F and H? 0 of course is one element, yes, but A does not appear in the second one. Because A is not there, we can say F is not equal to H. So, there goes H. Ciao. Okay, then gone. Last comes the comparison between G and H. 1 exists in both, but minus 1 is not here. So, G is not equal to H. So, there goes G. And H all by itself cannot be equated to anything. So, there goes H. So, only two sets of equal sets we have found out, that is, one is and set B is equal to set D and set E is equal to set G. Thank you. So, that ends the exercise. Dear friends, if any doubts occur while solving these problems, kindly please refer to the videos regarding the theory of finite sets, infinite sets, null sets and as well as equal sets. Okay, because further as we continue with subsets, and things are going to get little more difficult. Okay, it's little abstract there. So, I would urge you to go through the videos for the previous classes perfectly and then continue with the next. Have a nice time.